Good morning, everyone. My name is Vrunda Parmar. I am working as an assistant professor at Tulsiram Gaikwad Patil College of Engineering. Today, I am here to discuss about basics of nanotechnology and fundamentals of nanotechnology. So let us begin with it. So now here is a presentation layout. I will discuss all the points that I'm going to discuss now with you. So in the beginning, we will start with the introduction of what is nanotechnology. And in that, we will learn what is nanoscale, why do we use nanoscale, what is nanomaterial, nanoparticles. We will also discuss about various characteristics and various properties of nanomaterials. When nanotechnology started, we will discuss the history of nanotechnology and approaches of nanotechnology, how we can apply it in our day-to-day life, and different methods for synthesis of nanoparticles, that is bottom-up methods and top-down methods, and applications of nanotechnology. So let us start about what is nanotechnology. The design, characterization, and application of structures, devices, and systems by controlled manipulation of size and shape of materials of the nanometer scale, that is at atomic, molecular, and macromolecular scale. So to produce nanomaterials with at least one novel or superior characteristic or property. So here, nanotechnology is the science, engineering, and application of materials and devices at nanoscale. That is in between 1 to 100 nanometers. So 1 nanometer is 1 billionth of a meter. That means if we divide 1 meter into 1 billion parts, so the 1 billionth part of the meter would be considered as 1 nanometer. So at this scale, materials exhibit unique physical and chemical and biological properties that are different from the bulk forms. Okay. So why nanoscale? A nanometer is 1000 millionth of a meter. So people are interested in the nanoscale because of this scale, physical and chemical properties of materials differ significantly from those at the larger scale. As I said, when we use the nanoscale, when we use materials at nanoscale on like in presence of their bulk material, what happens is they change, or the materials exhibit unique physical, chemical, and biological properties. That is, they exhibit different properties at nanoscale level. That is why we use the materials at nanoscale instead of bulk. So, what is nanomaterial? A nanomaterial is any material that has unique or novel properties due to the nanoscale structuring. So, these are found by incorporation or structuring of nanoparticles. They are subdivided into nanocrystals, nanopowders, and nanotubes, a sequence of nanoscale of C60 atoms arranged in a long, thin cylindrical structure. So nanotubes are extremely strong mechanically and very pure conductors of electric current. Applications of the nanotube include resistors, capacitors, inductors, and diodes, and transistors. Nanomaterials are interesting because at the small scale, materials have fundamentally different properties than at the bulk due to increased surface area to volume ratio. So what happens at nanoscale level is increased interaction and reactivity is one of the byproducts of materials that are at nanoscale, which means potentially using less of the material, or that even on the nanoscale, the properties are so utterly different from that of the bulk scale. So what happens is, as we have already seen, that surface area to volume ratio of the nanoscale of the material at nanoscale changes. So when we use materials at nanoscale, the surface area to volume ratio increases. So when the surface area to volume ratio increases, more molecules are available for reaction, which increases the speed of the reaction. And that is why the reaction speed increases, which means we can use less material, or that even in the nanoscale, the properties are so utterly different from that of the bulk scale. So now let us try to understand what are the different characteristics of nanomaterials and why the characteristics change at nanoscale level as compared to bulk. So what happens is, as the particle size decreases, surface area increases relative to volume or mass of particle. Therefore, more surface atoms are available for interaction with surrounding environment. Hence, there is higher adsorption, faster reaction rates, better catalytic activity. So because of this property, the nanomaterial has various applications, like they can act as enzyme carriers. They are also used for drug delivery and antimicrobial agents. The next property is that nanomaterials exhibit unique properties at nanoscale because electrons behave differently. As they are confined in a very small scale, energy levels become discrete. So this changes optical, electrical and magnetic properties. Also, so what happens is because of high surface area to volume ratio plus more atoms on surface having incomplete bonding, nanoparticles are chemically more reactive. So for example, carbon nanotubes or graphene oxide, they are extremely reactive substances for attaching to biomolecules like DNA, antibodies, proteins, and they are used for targeted drug delivery and gene therapy. So now we are going to study what is the classification of biomaterials or nanoparticles. So nanoparticles are characterized or categorized into different classes based on their dimensions. So it can be 0-dimensional, 1-dimensional, 2-dimensional or 3-dimensional nanoparticles. So let's start with 1-dimensional nanoparticles. So in 1D nanomaterials, 2 dimensions are in the nanoscale while 1 dimension is elongated. So this material looks like thin wire or tube. So it has different characteristics like high aspect ratio, that is length is greater than diameter, excellent mechanical strength and electrical property, high tensile strength, easy to move inside body and enter cell. It can form aligned arrays or bundles. So where do we use this? We use it as natural neural tissue engineering, biosensors, and for drug delivery. Examples are carbon nanotubes, nanobelts, nanowires, or nanorods. 2D nanomaterials. So in 2D nanomaterials, one dimension is in nanoscale while the other two are extended laterally. So they resemble like sheets or plates. So in this, quantum confinement is only in one direction. So superior thermal and electrical conductivity, ultra high specific area. These are the properties of two-dimensional nanomaterials. Now let us discuss about three-dimensional nanoparticles. So they have no individual dimension in nanoscale, but the material is built from nanoscale building blocks like 0D, 1D or 2D arranged in 3D architecture. So the characteristics are they exhibit complex hierarchical or porous structures and can be isotropic or anisotropic depending on arrangement. They have improved mechanical, thermal and chemical properties. Now we will discuss about history of nanoparticles, like how nanotechnology started. In some senses, nanoscience and nanotechnology are not new. So chemists have been making polymers which are large molecules made up of nanoscale subunits for many decades, and nanotechnologies have been used to create the tiny features on computer chips for the past 20 years. So, however, advances in the tools that now allow atoms and molecules to be examined and probed with great precision have enabled the development of nanoscience and nanotechnologies. Let's understand what are the different approaches of nanotechnology, like how can we synthesize nanoparticles. So there are two materials basically used for synthesis of nanoparticles, that is top-down method and bottom-up method. So let us start with bottom-up approaches first. So in this approach, it involves atom by atom, molecule by molecule or cluster by cluster manipulation for the synthesis of nanostructures. It means that atoms are assembled into molecules are assembled into clusters and clusters are assembled to form a nanoparticle. This approach relies on self-assembly and controlled growth to create the desired nanoscale structure. So in this bottom-up approach, micro-patterning techniques such as photolithography and inkjet printing belong to this category. So bottom-up approaches, in contrast, use the chemical properties of single molecule to cause single molecule component. Self-organize or self-assemble some useful conformation. So here is a picture of how top-down approach or bottom-up approach works. So in bottom-up approach, we build the particles from small molecules. And in top-down method, we break the particles into small molecules. Now let us understand what is top-down approach. So in top-down approach, large materials are broken down into smaller and smaller components until they reach the desired nanoscale dimensions. That is, firstly, the bulk material is converted into powder form, and then the powder form is converted into nanoparticle. There are various methods like arc discharge method, electron beam lithography, mechanical grinding, etc., which are used to convert the bulk material into powder form, and powder form is converted into nanoparticles by chemical methods like sol gel process, electrochemical method, or microemulsion, etc. So now let us try to understand what are the applications of nanotechnology and where do we use this method of nanotechnology. So it is useful in medicine for diagnosis, drug delivery, tissue engineering, and cryonics. It is also used in information and communication as memory storage, novel semiconductor devices, novel optoelectronic devices, displays, quantum computers. It is used in heavy industry like aerospace, catalysis, construction, vehicle manufacturers. Also in consumer goods for food, household, optics, textiles, cosmetics, etc. and sports. Environmental applications include carbon capture sensors, where pollutant sensors that are able to detect lower limits with low cost. Also wastewater treatment. In case of energy, it is used for heat distribution. Example, ceramic like materials that provide sufficient reliability and durability of the entire structure. Thank you everyone. I hope you got the basic idea about what is nanotechnology, the history of nanotechnology, the classification, and also the application of it. Thank you.